Sana Army, it's me again, Auntie Pumeza. Let's keep rolling. Today we're doing lesson 2, and here we're going to be treating multiples, factors, and fractions. There are also things that you learned maybe grade 8, grade 7, grade 8, grade 9. I think that's where they were introduced, but you have forgotten them. Don't worry. Auntie Pumeza is here to remind you. They are also very important in maths. They are handy tools that you will see. We will use them a lot. So it's important that we remind each other. What are these? Okay, let's start with the multiples. What are multiples? Do you still remember, guys, in your grade 1 when you were taught how to count in fours? For example, you would say 4, 8, 12, 16, 20, 24, or 6. You would count in 6. You would say 6, 12, 18, 24. These are actually your multiples. What you were taught in grade 1, although they were not called multiples, they are multiples. And now in high school, they're going to come in very handy. Knowing multiples, it's important because they help us solve a lot of problems quicker and in a flawless way. Okay, so we're not just going to look at multiples, but we're going to look at something that is called common multiples. If you see, these are multiples of 4 and these are multiples of 6, but you see that they have common, both of them. For example, you have 12 here and you have 12 here. You also have 24 and you have 24 here. So we say 12 and 24 are both multiples of 4 and 6. Okay, so most of the time when you're asked a question, it won't be just list the multiples of whatever. You will be asked to find multiples of 4 and 6 and then maybe find the common multiple. So we call these common multiples. So 12 and 24 are common multiples of 4 and 6. What we are looking for, which is very important in maths, is the lowest common multiple. Out of these two numbers, there are so many of them, of the common multiples. If you continue counting in 4s or in 6, you will find more common multiples. But we are looking at the first one, the very first one that is common, which we call the lowest common multiple. Guys, this is important. Lowest common multiple is very, very important in maths. You are going to see just shortly how we are going to apply it. But mastering it, finding the lowest common multiple, it's very important because it makes our life much, much easier. Okay, let's move on to the second one, which is factors. Let's move to factors. What are factors? Factors are numbers that when you multiply them, they give you that number. For example, if I say factors of 12, I'm looking for the numbers that they divide exactly to this number. Okay, they divide exactly to this number and they do not leave a remainder. Let's look at them. For example, if I divide 12 by 1, I do not get any remainder. So 1 is a factor. I also look at another one. I say the second one, if I divide 2 here, 2, it doesn't give me a remainder. It gives me a 6, no remainder. So 2 is a factor. And also the third one, 3, yes, also 3 is a factor of 12 because if I say 12 divided by 3, I get a 4, no remainder. So 3 is a factor. Also 4, if I say 12 divided by 4, I also do not get a remainder. So 4 is a factor. But is 5 a factor of 12? If I divide 12 by 5, I get a 2 and a remainder 2. So I have a remainder there. So 5 is not a factor of 12. Actually, and then the last one will be 12. Oh, sorry. Then the other one will be 6. 6, if I divide 6 there, it's also a factor. And then the last one will be 12. So all of these numbers, 1, 2, 3, 4, 6, and 12, they are the factors of 12. They are also important, guys. Also, factors are important. Okay, even here we're going to look at the common factors, but we'll look at that later on. What I want you to, guys, a tip I want to give you is for you to actually be careful when you're listing. Can you see that 12 has got 6 factors? Okay, there are numbers that have many factors. So for example, let's take 36. 36 has 9 factors, okay? You might be asked in your question to list all the factors. They will say all the factors. It means, guys, you must list all of them. 36 has got 9 factors. If you list 8, you will be wrong. And you will fail maths. And you will wonder, why are you failing maths? Because you have forgotten one when the question says all. So here's a trick on how to make sure that you list all of them. You do not miss anyone. List them in pairs. Remember when I was looking here, when I was saying 1 goes there, it's actually what's the number that I can multiply here to, it's 12. So for example here, you start at the beginning 1. So you say that the factors of 12, if you multiply 1 by 36, you get a 36. 2, you multiply by 18. 3, you multiply by 12. 4 as well is a factor of 36 because you can multiply it by 9. Okay? 5 is a 5. No, it's not a 5 doesn't goes to 35. 36 will give you a remainder 1. So it's not a factor of 36. So we leave 5 and 6. Yes, you can multiply 6 by 6 and get 36. So all of these are factors. And when do you actually stop? You stop once you have a repeat. Okay, let's move on. 7. Now 7 is not a factor because you will get it's actually a 35, and then you also get a remainder 1. So it's not a factor. You jump 7 and you could go to 8. Is 8 a factor? No. The last number before 36 is 32. 8 times 4 actually. 8 times 4 is 32. So it's not. So there will be a remainder here, a remainder 4 here. So 8 is also not. So let's move to 9. 9. But we already have 9 here. So that's when you know you need to stop. The moment you repeat, then you know that you have to stop, because it will keep repeating. You keep repeating all these numbers. So now you have all your numbers, okay? And you can just list them. You can just say 1, 2, 3, 4, 6. You don't repeat 6. See, it's repeating here. So you write it once, 6, and then 9, 12, 18, and 36. Those are all multiples. When you're answering a question, you can list them. That are all multiples. Multiples of 36. So guys, that's very important. If you are told to list all of them, please list all of them. I always do it like this so that I do not miss anyone. Okay, so that was for factors. Okay, but we're not really interested in factors as all of them, like all of these factors. There are 2 kinds of factors that we're interested in. The first one is the common factors, okay? Common factors, so you will be given 2 numbers. You'll be given 2 numbers. Remember we said the factors of 12 actually 1, 2, 3, 4, 6, and 12, okay? We can also look at the factors of 18. Factors of 18 are 1, 2, 3, 6, 9, and 18. Okay, so these are the factors of 18. These are the factors of 18. Okay, so you can see that we have common factors here. All of these are common factors. All of these are common factors. What we're looking for here is, what we're most interested in is the highest common factor. Okay? The highest common factor. Out of all of these we've listed here, 6 is the highest common factor of these 2 numbers. So we would say 6 is the highest common factor of 12 and 18. This is very important, guys. We will see just shortly. We will apply this and then you will see why we need it. It comes in very handy. The more you know how to find your factors, the better. Okay? Another one which we will not apply in this lesson, but we'll apply later on in the later lessons, is what we call the prime factors. Okay, it's what we call the prime factors. Okay, what are prime factors actually? Prime factors, I hope you still remember what prime numbers are. Prime numbers are the numbers that you can only multiply by itself or by 1. So divide by itself or by 1. Let's take for example 3. 3, in order for you not to get a remainder, you can only divide 3 by 1, which you will get a 3, or divide 3 by itself and you get a 1. These are the only times where you will not get a remainder. The moment you divide 3 by any other number, you will always get a remainder. So we call 3 a prime number. So there are other prime numbers. Okay, the trick on how to remember prime numbers is that, remember, you have even numbers and odd numbers. All the real numbers are made up of even numbers and odd numbers. Okay, so the only even number that is a prime number, only even number that is a prime number is actually 2. So the moment you have an even number and it's not a 2, just know it's not a prime number. Then odd numbers, it's not so easy to find them, but you can just check them. At least know the first 20 up to 20. So for example, 3, 1, 3, 5, 7, 11, 13, and 19. So up to 20, these are your odd numbers that are actually prime numbers. So actually your prime numbers from 1 to 20 will be 1, 2, 3, 5, 7, 11, 13, and 19. So here we are going to find prime factors. What are prime factors? Prime factors are actually numbers. They are factors that are actually prime numbers. So we go to 12, for example. All these, we said all of these are factors of 12. But which of these are prime numbers? We said 1 is a prime number, 2 is a prime number, 3 is a prime number, and that's it. Those are not, because they are even numbers. The moment they are not 2 and they're even numbers, they are not prime numbers. So 12, the prime factors of 12, it's only 1, 2, 3. Okay, same as here. The prime factors are 1, 2, and 3. Okay, so this is very important as well, guys, but we'll apply it later, not today, as well. Okay, now let's move to the gist of this lesson. Fraction. Guys, I don't know what's wrong with fractions. Most of the students do not understand fractions. Why, guys? Why? You do fractions in the kitchen every day. When you slice up a cake, it's fractions. When you weigh things, cooking, it's fractions, guys. You are taking from a packet and you're taking a fraction. You're just doing fractions every day. But don't worry, Auntie Promesa is here for you. We are going to do fractions. Remember, I said maths is about rules. For you to understand fractions, you need to understand the rules. Okay, but let's first start with the first one. First thing, which one is greater? Okay, with whole numbers, let's say with whole numbers, if you are given whole numbers 4 and 6, it's easy to tell which one is greater. You just say 4 is less than 6. Okay, even if you are given negative numbers, so -2 will be greater than -6. Okay, I hope you do remember that when you're going the negative way, the bigger the number, the smaller it is, because we are in the negative. So -2 will be greater than your -6. So it's easy to tell. But with the fractions, how do you know it's greater? Okay, there are 3 scenarios. Okay, the first one is if you have denominators. Remember, your fractions are like this. Okay, so if you have your denominators, let's say, for example, 7 and 7. Okay, check your denominators. If you have the same denominators, you just check your numerators. The one with the bigger numerator is the greater one. It's easy when your denominators are the same. The greater one is the one with the biggest numerator. Okay? And then when you have when your denominators are different but your numerators are the same, what do you have? What happens when you have your numerators the same? Your denominators can be different. How do you know? The one with the largest denominator is the smallest. If the numerators are the same, the one with the largest denominator is actually the smallest. So you have something like this. So the one with the largest denominator is actually the smallest. Don't forget those rules, guys. They are very, very important. Don't forget them. They are so, so important. But what happens the third scenario? So this was the first one. The denominators are the same. The second one, the numerators are the same, but the denominators are different. The third one, you have a scenario where both the denominators and numerators are not the same. So you have 2 over 3. And then you have 4 over 5. So here, both the numerator and denominators are not the same. How do you know which one is bigger? Remember, this is not a whole number, so it's not easy to see which one is bigger, which one is smaller. So what do you do here? You do what we call the cross multiplication. So you will multiply the numerator of this one with the denominator of that one, and do this. Okay. When you do the cross multiplication here, be careful that when you multiply the numerator of this one, you always write the answer this side. Okay? So you say 2 times 5 is 10. Okay? And you multiply these two, this will be 12. Okay? And then you can tell, because now they are whole numbers, you can tell which one is greater. So 12 is greater than 10. So now you can easily see which one is greater. Okay? The same thing you do here, you just do it there. That's why it's very important that when your numerator is this side, you write what you are multiplying on this side so that you have the same. So you must first do the cross multiplication. Whatever whole numbers you have here, or integers, it could be integers, it doesn't matter, as long as they are not fractions. The integers you have here, what you do is whatever sign you have here, it's the one that you're going to have here. So this is how you tell fractions that are not the same, that don't look alike. They don't have the same numerators, they don't have the same denominators. So this is how you actually tell them. Okay, so that was our first lesson. You must be able, sometimes you'll be asked, write your numerators, write your fractions in descending order, which means you start with the biggest until the smallest. Or you'll be asked to write them in ascending order. You write the smallest up to the biggest. Just know this, guys. Just know these rules. There are 3 cases. Just look at the denominator. Is the denominator the same? Then the bigger one is the one with the bigger numerator is the larger fraction. Here, when the numerators are the same, the denominators are different. You look at the one with the largest. The one with the largest denominator is actually the smallest. So this one is smallest because it has the largest denominator. And then when they're not the same, you do the cross multiplication. And whatever sign you put here, you come back and put it here. I hope that was easy, guys. It's how you must tell which one is greater. It's very important as well when you are interpreting. We are going to do a lot of interpretation in maths. We are going to understand these numbers. Now I want you guys to understand why you do maths, okay? I don't want you to get bored because you do not understand. In my lessons, you must know why you do maths so that you don't get bored. So we'll do a lot of interpretation. This work that I'm doing here will come in very handy. Once you know it, will come in very handy. Okay, so the next thing I need you guys to know is equivalent fractions. What are equivalent fractions? It's when you write a fraction in a different form, but they mean the same thing. Okay? Let's take, for example, half and 2 over 4 and 4 over 8. all of these guys are equal. Okay? They are written in different form, but they're actually the same. They mean the same thing. Okay? So why do we need to talk about equivalent fractions? Because we are going to need, there are times when you have to write a fraction, you have to convert this and write it this way. We are going to see just now. In this lesson, we are going to see how we apply equivalent fractions. Because sometimes it's easier to write a number in a different form. This does not just, equivalency does not apply only to fractions. It's applied to any number. For example, you have 4. 4, you can write it as 2 squared. You have written it in different forms. But why do you do that? Because sometimes it is more convenient to write it this way, especially if you're dealing with powers. It's more convenient to write 4 this way. Sometimes it is convenient to do this way. Or you can even write it in the square root. You can say square root of 16. All these are equivalent because they mean the same thing. So even in fractions, it's very important to know the equivalent fractions because we are going to need them when it's convenient. Okay? Now let's move to the rules when you're adding. Remember I said everything in maths, it's about these guys. These are powerful guys. Okay? So when you're doing, you're adding fractions and you're multiplying or dividing fractions. The rules are not the same as when you are dealing with your integers. Okay? When you're dealing with your integers, if I give you 2 times 3, you just go and that's it. But if I give you 2 over 4 times by 6 over 7, you don't just go around, let me do the plus, which confuses you. You know, you don't just add like you would 2 and 3. You need rules on how to actually do the maths, the plus, minus, the times, and the divide. I keep forgetting the divide, guys. Auntie Pumeza is old, so she keeps forgetting. So, guys, okay. Now let's start with the plus and the minus. What are the rules for the plus and minus? We have 2 cases here. If you have the denominator, it's very important that when you're doing, when you're separating or adding fractions, you look into your denominator. So your denominator, the first case is your denominators are the same. If you have the same denominators, okay, you can have whether you're plus or minus. It's easy. The rule is easy. You just add the numerators. If the denominators are the same, you just add the numerators. So you will have 5 over 7. Okay? So you will have 5 over 7. And that's it. Remember, guys, always write your answers in the simplest form. I actually forgot when I was doing the equivalent form. So let's go back there. You had half, 2 over 4, sorry, and 4 over 8. So these are all equivalent forms of one fraction. But there's only one that is in the simplest form. It's this one. And a fraction is, or a number is, let's say a fraction in this case, a fraction is in its simplest form when it does not have any factors between the numerator and the denominator. If you look here, there are common factors here because there is a 2. Remember, the factors of 2 are 1 and 2. The factors of 4 are 1, 2, and 4. So you do have a common factor which is 1 and 2. So you have common factors here. And then this one of 8, actually this is not a good example to be, but anyway, so you have the only common factor here will be 1, but here you have more than one common factor. Even here you have more than one common factor. So these are not in simplest form. You can reduce them into their simplest form. This is the only one with this that is in its simplest form because the only common factor between them is 1. Okay, so a fraction is in its simplest form when the only common factor between the two numbers, between the numerator and the denominator, is 1. So always make sure that when you report your answers, you leave them in their simplest form. So this is the simplest form because there's no common factor here except 1. There's no common factor between 5 and 7, so we leave it in its simplest form. Okay, so let's move on. So this was a case where the denominators are the same. What happens when the denominators are not the same? Oh, by the way, you do this with a minus. If I just change a minus here, the same rule applies. So it will be 2, because the denominators are the same, you just subtract 2 minus 3. Remember those rules we did in lesson 1? You subtract and take the sign of a bigger number. So that will be minus 1. So the answer will change here and be minus 1. So now let's look at the situation where the denominators are not the same. Let's say 5. Okay. The first thing you need to do here is to make this, the denominator to be the same. Because once the denominators are the same, it's easy. You apply this rule here. So the first goal is to make these the same. How do you do that? You use what we just said, the equivalent fractions. We must write these in their equivalent form, not in this form. Which equivalent form do we write? Because we have seen that a fraction can have many equivalent forms. Which one do we choose? We use again what we did in earlier on, which was the lowest common multiple. So can you see where we apply it now? The lowest common multiple, it comes in very handy. It comes in very handy. So we're looking for the lowest common multiple here. If you count in sevens, I'm not going to count, and count in fives, the lowest common multiple that you will find is 35. So 35 will be your lowest common multiple. So our goal is to make the denominators to be 35. So let me write it here. This is our goal. We want the denominators to be 35, both of them. But how do we make these 35 without changing? Because remember, equivalent means that you're not changing the value stays the same. So how do we make these to have denominators of 35 without changing the value of this? Then we multiply on both sides. So you're going to multiply by something on both, okay? So here, in order to get to 35, you must multiply by 5. In order to get to 35, you must multiply by 7, okay? And then what you do below, you do on top as well, and you do here, okay? Now you have 7 times 5 is 35, 5 times 7 is 35, but you have 10 here, and you have 21 here, okay? Now if you can change this, let's erase this. If you look into that, this is exactly the same as this one. It is just in its equivalent form. If you can reduce this, because it has the factors, can reduce by the highest common factor. The highest common factor is 5. So if you can reduce by 5 here, you ask how many times that 5 goes there? 2 times. How many times does 5 go there? 7 times. You go back there. So you haven't changed the value of this fraction. You have just written it in its equivalent form because it is convenient for us to have both our denominators the same. Then we can apply this rule over here. Okay, let me make another example which doesn't, because you will always think that you always multiply this by this. If you have seen here, in order to get a 35, I multiply by 5 here, I multiply by 7 here. It does not always work like that, okay? It will work, we won't be wrong, but you'll be working with the different bigger numbers. That's why it's very important. You must always choose the lowest common multiple, not any other multiple. Let's look at another example. Let's say 5 over 12 plus 3 over 8. Okay. Now let me change this. I'm looking at multiples. not, let me make it simpler. Let's say 4 and 8. Okay, it's fine. Say 4 and 8. No, I want a better example. Okay, let's do that. 6 and 8. So let's look at the multiples of 6. So you have 6, 12, 18, 24, and so on. And you have 8. Multiples of 8 are 8, 16, 24, and so on. 32, and so on. Sorry, 32. Okay, so here, if you did what I told you here, when you're finding the lowest common multiple, if you did what I said here, which is 6 times 8, 6 times 8 is 42, right? 6 times 8 is 40, sorry guys, it's 48. 6 times 8 is 48. So if you did that, you will get 48, which you are not wrong, but it's a bigger number. But if you use the principle that you must use the lowest common multiple, the lowest common multiple between 6 and 8 is actually 24. So you would have the denominator, which is 24. Do you see now that you have reduced your number? So it is going to be easy for you to actually work with that. Okay, now let's continue with our so you would have here 24, 24. You must multiply by, to get 24, this will be your 6 times 4. We do the same here. 8 times 3, do the same here. Okay, so you have 5 times 4, which is 20, and you have your 3 times 3, which is 9. Now your denominators are the same. Now you can go on actually and apply the same rule here, which will be 29 over 24. Okay, 29 over 24. Never, this is an improper fraction. This is an improper fraction. Never leave your answer in improper fraction. Sometimes it depends on the marker or the guideline they're following when they're marking. Sometimes they may give you full marks, but sometimes they may subtract the mark. To be on the safer side, never leave this in the improper fraction. Always convert it into mixed. So you would say that's 1 and 5 over 24. That's 1 and 5 over 24, and you leave your answer like that. So those were the rules, guys, when you're adding or subtracting fractions. Check the denominators. If the denominators are the same, then it's easy, you just add or subtract the numerators. But if denominators are not the same, then your first goal is to make them the same, and you use the lowest common multiple. Find the lowest common multiple, and that lowest common multiple is going to be the denominator. Okay, once it's the denominator, once you have found the denominator and you multiply everything to make it the lowest common multiple to be the denominator, then you can continue adding the same way, because now your denominators are the same. Now you can just add the numerators. Okay, so that's it for the addition and subtraction of fractions. Okay, so guys, some of you may have forgotten how you actually can convert an improper fraction to a mixed fraction. Okay, so remember here we got 29 over 24. Let me start with explaining what an improper fraction is. It is when the numerator is greater than the denominator. So we see here it's the numerator is greater than the denominator. So it means we have the improper fraction. So how do we move it to a mixed fraction? We actually say, okay, we ask how many times does 24 go to 29? 1 time. So it's 1 time. Okay? You will only, if you have 29 and you will take 24 out of these 29 pieces and you take 24, there will only be one chance for you to take 24, because you'll be left with less. So there's only 124 in 29. So you have 1. And the remainder, what is the remainder when you take 24 out of 29? The remainder is 5. So you just write 5 and then you keep your denominator as 24. Okay, I hope you guys still remember this, how you convert from an improper to a mixed fraction. Okay, I also want to note why is there a need to write in this? Okay, remember I said maths is about solving our everyday life problems. Let's say you are told to write a report for your boss, for example. When calculating, it is easier to calculate using improper fractions. Okay, so when you're doing your calculations, it is convenient to use improper fractions. But now you are reporting to them. You are saying 29 over 24. How do they picture that? What is 29 over 24? But if you report it in mixed, they know that, oh, it's one part. So it's a one whole thing, and then 5 out of 24. So they can actually visualize it. When you report it in this way, they can actually visualize it and say, okay, it's one whole, and then the smaller parts, 5 small parts out of the 24. So it's easier to read it in mixed than in improper. But to calculate, it's easy to do it in improper than mixed. So you must always be able to switch between these two when you're dealing with improper fractions. Okay guys, so we've just done the rules plus and minus when we are dealing with fractions. Now let's move on to when you're multiplying and dividing fractions. These actually are the easiest. Okay guys, these are the easiest. Let's start with the multiplication. They are a bit different, not that different, but we are gonna have a bit of a difference here. They're not exactly as when you're plussing or minusing. So let's start with the multiplication. So let's say you have 2 over 3 times by 1 over 4, for example. Okay, so the rule is very simple. When you're multiplying, you just multiply the numerators and you multiply the denominators. Okay, so you can say 2 over 12. Okay, you can just say 2 over 12, and then because this is not in the simplest form, remember I said, guys, always leave your fraction in the simplest form. Then you have to actually write in the simplest form. You ask the highest common factor here is 2. So you have, how many times does 2 go here? 1, and here 6 times. So you have 1 over 6. Okay, but guys, you can skip this. You can skip this step, especially when you're dealing with bigger numbers. Let's make another example. Let's say 12 over 16 times by, let's say, 3 over 2, for example. Okay, okay, let me do this. Okay, if you do this step, you will end up with something like, this is 36 over 18. Okay, this one was much easier. I need another one. Let's say 15. Okay, and then you have 30 here. Then now you have to reduce this into asking the factors that go there, the highest common factor. This may become complicated. So what you need to do actually is to reduce it here. Before you can actually multiply, before you can apply the rule of multiplying the numerators together and the denominators together, reduce it here. Whenever there are common factors, you actually reduce. Okay, so here you have common factors. Actually, you can do it either way. So I'll do here, 3 and 5 are common factors. And then, 3 and 15 have common factors. And the highest common factor is 3. So you ask how many times does 3 go here? 1 time. How many times here? 5 times. Also 2 and 12 have common factors. You ask how many times does 2 go here? 1. How many times does 2 go here? 6 times. You could have done even here. These have common factors, okay? 3, for example, is a common factor of this. You could have done it here, but it was much simpler to do it here. So now you have 6 over 5 times 1. Actually, 1 over 1. Okay? 1 over. So it's much easier now. You say 6 times 1 is 6 over 5. Instead of going there and then you can say 1 remember this is an improper, so you need to put it in improper. So you say, how many times does 5 go to 6? 1 time, and the remainder is 1/5. Okay, you would have gotten the same answer here. So you're not wrong by not looking for the highest common factor here, but it would have made your thing complicated, because you, especially when you're dealing with much bigger numbers. So here, okay, it's still 1, and then you would say 6/30, and again reduce this, okay, and reduce 6/30, which is going to be 1/5, and you end up with the same answer. So it's not wrong, but you applying those highest common factors. Remember, I taught you about highest common factors, that they come in handy. So applying them here makes your work less complicated. It makes it less complicated, and you can actually finish it much earlier than when you do not apply them. So one other thing we are going to do is to teach you how to use the shorter routes. Okay, we are going to work smarter. We are not just going to work harder, but we are going to work smarter, because when you follow this longer route, it's easy for you to make errors. It's easy for you to make errors, but if you apply these smart techniques, then you get into the answer much quicker. Okay, guys, that was the multiplication. It's the simplest of them all. Multiplying fractions, you just multiply the numerators together, the denominators together. But if you have any common factors between the numerators and the denominators, you must first deal with them so that your work is less complicated. Now let's go to the division. Division, what do? Let's say, I like 3, guys. I can't even pronounce it. I'm Xhosa, so our 3 is, I don't even know how to pronounce it, but I love it. I don't know, it's one of the numbers I love. So let's just use it. And then you are dividing by 6/7. Okay? So the rule here is that when you are dividing, the first goal is to change this division sign into multiplication sign. Okay? So you change this into multiplication sign. You don't just change it. There's a rule for changing it. Remember, you must not change the value of these things. So the rule for you not to be changing the value of this while you are changing this sign into multiplication is that you must change this thing here. Okay, let me just introduce something. So if you have here a number and you divide by another number and you get your answer. Okay, in division, maybe you did this in your grade 3 or 4, I'm not sure. You call these, there are special names for these things. This is called the dividend. This is called the divisor. And this is called the quotient. It's very important to know that, okay? They're not important in multiplication or whatever, because you can switch. 2 times 3 is the same as 3 times 2, okay? But not with division. You cannot say 12 divided by 4 will give you a 3, all right? But you cannot say 4 divided by 12 is 3. No, it's something else. It's actually equals to 1/3, okay? So they are different. These are 2 different numbers. So it's very important to know which one is the divisor, which one is the dividend. So this one on the left is always the dividend, then the divisor, then the quotient, okay? So when you are dividing fractions, you must also know the divisor. So the rule when you are dividing is that you first change this into a multiplication sign. But the rule says that you must swap your divisor. So the divisor is always the one on the right. So swap this divisor. Make the numerator the denominator and the denominator the numerator. So you would say 7/6. So that's the rule. You don't just change it. You don't just swap from division to multiplication. You must also swap your divisor. Your numerator must become the denominator and the denominator the numerator. This you leave it unchanged. Okay, you leave it unchanged. Once you are in the multiplication now, you can apply the multiplication rules, which are you just multiply the numerators and the denominators. If there are any common factors, you deal with them. For example, there is a common factor between the numerator and the denominator here. You ask how many times does 2 go there? 1. And how many times does 2 2 go there 3 times. Becomes easier. So you say 1 times 7, it's 7. 3 times 3, it's 9. It takes me straight to the simplest form. I cannot reduce it further. It's in its simplest form, and then I'm done. So those are the rules for the division, guys. And that's it about the fractions. This is the most important, guys. I do not understand why you don't like fractions. Please keep these rules. Don't treat fractions as integers. They are not integers at all. They are not integers. Do not apply the rules you learned in your first grade, second grade, when you are adding or subtracting, when you are dealing with fractions. Learn these rules, especially the addition and the subtraction one. They are the most important. They are the ones you are missing out. You just apply, because the multiplication is easier. You just multiply the numerators and denominators. You apply that rule in everything, and that's where you're getting it wrong. You may understand the concept, but if you're not applying these, let's say for example, you are given, you are doing algebra. Now we are gonna go to serious stuff. Let's say you are given algebra, say 1 over 4 x plus 2 y plus 3 over 2x. Okay, you're supposed to be adding these. Okay, equals to whatever, even if, so you're supposed, the rule will get there, we'll explain this, we'll get there. But let's just say you also did it in the lower grades. Let's just say, so the rule will be that you add these two, right? You add these two, so you'll have x 1 over 4 plus 3 over 2. Okay, because you're adding these two. Okay, now if you do not understand your fractions, you may understand that rule that you only add the ones with the same bases. Okay, when you're adding, it must be the same bases and same powers. So you might understand that rule when we come to this section. You may understand it very well, but because you have missed that you are dealing with fractions here, not integers, you will get a wrong answer. So it's very important to understand your foundation work, because it's helping you. They will not teach you in your grade. They don't cover this stuff because they expect you to know it. You're supposed, fractions were introduced, I think, in grade 6. Fractions, or even in grade 4, they will introduce how to add or subtract fractions. They were introduced in your lower grades. So now in high school, they don't teach you because they expect you to know this stuff. That's why Auntie Pumeza is here to remind you guys, so that you know this foundation and be able to apply it in your grade, in your work. Okay, guys. So we've come to the end of our lesson. Thank you very much. God bless you.